Now I'm going to convert the second methodology, second methods, so that the second equations are given like this. Okay, so that suppose the equation is given. Write down minimize whatever it is, minimize or maximize, whatever it is. So maximize, supposed to say z is equal to, now take this as a, forget about the maximum or minimize, z is equal if the equation is given. So 6x1 plus 7x2 plus 8x3 subject to constraints. So x1 plus 2x2 plus 7x3 greater than or equal to 4. Now 2x1 plus 3x2 plus 8x3 greater than or equal to 6. Next x1 plus 4x2 plus 7, 9x3 greater than or equal to 5. Now the value is x1 comma x2 x3 greater than or equal to 0. Three variables. Now what are our logic point? Please draw this. What are the logic point here? Their logic point is less than or equal to, greater than or equal to, and equal to. Now slack variables, artificial variables, and a slack variable. Again, it is divided into two categories: less than or equal to, greater than or equal to. Leave it. Now conversion is very important. So what is the first to write down? Z is equal to, first you write equation as it is, 6x1 plus 7x2 plus 8x3. Now subject to constraint equations means x1 plus 2x2 plus 7x3, this greater than or equal to. Greater than means you have to take the variables artificial and a slack variable. It means a1 plus s1 or 1s1, whatever it is, equal to 4. First equation. Go to the second equation, 2x1 plus 3x2 plus 8x3 plus second equation. So a2 plus s2 equal to 6. So automatically inequality equation convert into equal equation. So x1 plus 4x2 plus 5x3 plus a2 plus s3 equal to 5. So what are the equation here? So x1 comma x2 x3 a1 a2 a3 and s1 s2 s3 greater than or equal to 0. All are commas, all our variables is there. Okay, so the problem is over. Now come to this point here. How to convert the maximum equation? Maximum plus s is there. S is the value of the slack variables in objective function. All are equal to 0 only. 0 s1 plus 0 s2 plus 0 s3. 0 s3 plus. Come to the point. A is there. So in this one, if you want to introduce A, that method is called as a big M method. At the time of solving the problem, I will explain how to calculate or how to find the value of big M method. So please write down A1 plus A2 plus A3. So this is a case 2. Case 2 method is a over. Okay. Now, so conversion is a over. I'm going to explain something about case 3. Case 3 means here, case 3, Z is equal to, case 3. Now, dear students, now I'm going to explain the case 3 model. Case 3 means of a mixed type of the problems. Please note on the equations. Equations means, for example, to say Z is equal to, Z is equal to 3x1 plus 4x2 plus 6x3. This is a case 3 type. So subject to constraint, so x1 plus 2x2 plus 9x3 is a one is a less than or equal to 5. Another one is a 2x1 plus 4x2 plus 7x3 greater than or equal to 6. Now x1 plus 3x2 plus 5x3 equal to 7. So x1 comma x2 comma x3 greater than or equal to 0. Now the problem is given like this. Solve by simplex method. Now how to solve the problem? So according to our of a basic concept, what is the basic concept here? So one is a less than or equal to, another one is a greater than or equal to, another one is a equal to type. So here is a slack variable, introduce a slack variable. Here is artificial slack variable. If the question is given like this, you have to convert the equal equation into two other types. That is a less than or equal to, another one is a greater than or equal to. Now this see, this is the first equation less than or equal, it's no problem. Second equation is greater than or equal, it is given in a proper order. But third equation is not given in a proper order, that is given in a equal to method. Now first of all convert, that is the first equation. So subject to constraint, please convert like this one. First you write down the equation like this: x1 plus 2x2 plus 9x3 less than or equal to 5. It means that you have to write x1 plus 2x2 x1 plus 2x2 plus 9x3 less than or equal to means plus 1s1 equal to 5. Go to the second equation. So 2x1 plus 4x2 plus 7x3 greater than or equal to 6. So how to convert the equation? So that is a 2x1 plus 4x2 plus 7x3 greater than or equal to. Greater than or equal to means use a better to take the help artificial and slack variables. So a2, this is the a2 minus s2 equal to 6. Sir, why you are not using a1? Because a2, this is a a2, the artificial variable is a connected to second equation. So that you have to write down a2, don't write a1. Now come to the third equation, conversion of the third equation. But the third equation is given like this. So what is the type here? I mean to say the third equation is given x1 plus 3x2 plus 5x3 equal to 7. But according to the definition, if the equation is given equal to, you have to convert the equation into two ways. Two ways means one equation is x1 plus 3x2 plus 5x3. One is a less than or equal to 7. Another one is a x1 plus 3x2 plus 5x3 is a greater than or equal to 7. Next convert here only. Here it means that x1 plus 3x2 plus 5x3 less than or equal to, yeah, add s. So already s2 is over plus 0 of s3. So s3, 1 s3 or s3 is equal to 7. Go to the last equation. So x1 plus 3x2 plus 5x3 greater than or equal to an artificial slack variable. A2 is over. A4 minus S4 equal to 7. So what are the final equation here? What are the final? X1 comma X2 comma X3 S1 comma S2, because S2 is over, S3 S4 comma A2 A4 greater than or equal to 0. Now come to the point of subject to function. So how to convert the Z equation? Z equation is a 3x1 plus 4x2 plus 6x3. It means how to convert the equation here? 3x1 plus 4x2 plus 6x3 plus a1. So 0, the value of slack variables in the objective function is always equal to 0. This is called as objective function. This is the objective function. Objective function. So 0s1 plus 0s2 plus 0s3 plus 0s4 plus a2 plus a4. This is a third case, conversion of the third case equations. Now, once this part is over, now simplex table. Simplex tables means of how to write the simplex table. Simplex table means come to this point. Now come to this. Yes, come to the simplex. Next point is a simplex. Simplex. Simplex table. Simplex table is a standard tabular form. Standard tabular form means, for example, take this is one type of the logic, how to enter the variables into another equation. For example, take this, this is there. Suppose the equation is there, 3 variables. So you have to write, this is the CI, basic variable, second column, basic variable, solution value, solution values. Next, if the equation contains 3 variables, suppose to say that x1, x2, x3, slack variables are 3, s1, s2, s3. If any artificial variables is there, a1, a2, a3. Next, the question is like this, column wise, column is like this, like this. This is the last one is a minimum ratio. This is the standard format of the simplex table. This is simplex table. Now, today, I'm going to explain how to enter the basic, of variables, particularly in a simplex table. Suppose point to point, take any one problem, solve by the problems given like this in examination point of view, like this. Solve by simplex method. Simplex method. Now z is equal to, problem is given like this, 2x1 plus 3x2 plus 4x3. Now subject to constraint, x1 plus 2x2 plus 5x3 less than or equal to 6. Now 2x1 plus 4x2 plus 7x3 is a less than or equal to 8. The 3x1 plus 6x2 plus suppose sometimes 9x3 less than or equal to 11. The problem is given x1 comma x2 comma x3 greater than or equal to, given like this. The question is given in examination point of view like this only. Now come to the conversion is very very important. First to take the subject to equations wise in examination. First you write like this. So it is a less than or equal to according to our methodology. What is the methodology? What is the logic point here? Less than or equal to, greater than or equal to, and equal to. Less than or equal to means slack, introduce slack variables. Here is artificial variable, slack variable. Again is a divided to main category, that is the second element. Now come to the conversion. Conversion is very very important point. So x1 plus 2x2 plus 5x3. Again come to the unit matrix. This is a simplex method is always connected to unit matrix. Unit matrix means 1 0 0 0 1 0 0 0 1. So this is the way. Understand? Come to this point. Unit matrix. So first equation, you have to take the one diagonal type of view. So that is a 1 plus 1 S1. There is no 0 S2 plus 0 S3 is equal to 6. Now the second equation. So how to convert the second equation? 2x1 plus 4x2 plus 7x3 plus 0 S1, because second equation, because the 1 is there, second point. So that 1 S2 plus 0 S3 equal to 8. Now come to the third equation. How to convert the equation? 3x1 plus 6x2 plus 9x3 plus 0s1 plus 0s2 plus 0s3 equal to 11. Now x1 comma x2 comma x3 comma only slack variable. There is no artificial variable, so that you have to show in slack variables only. S3 greater than or equal to 0. But the last point, please convert into objective function value. So how to convert the objective function? 2x1 plus 3x2 plus 4x3. It is only artificial slack variable. The value of the slack variables in objective function is always equal to 0. So 0s1 plus 0s2 plus 0s3. Everybody knows this one. Now, the point is how to enter coefficients in the particular tabular form. This is called as a simplex table. So, first you write down simplex table. Simplex table. Okay. Simply, how many this one is there? 3 variables, 3 slack variables. No problem. First, draw the horizontal line here. Horizontal line here. Next, first you write down CI. CI means ith column jth row like this. Next one is a basic variable. Variables. Next, first you write like this one. This is a solution values. Solution solution values. Next one, 3 variables: x1, x2, x3, s1, s2, s3. The last value, column value, minimum ratio. Minimum ratio. So that this is a standard and fixed tabular form in simplex method. Now the question is how to enter coefficients in the tabular form. In the tabular form, that is a very important point. So examination point of view, 1 or 2 questions are related to simplex method. Only logical point. Even next, this is a see. Next, you continue like this. Okay, this is the there. Okay, now this is a CJ. CJ, you write like this. CJ. CJ means take the first equation. What is objective function value? Write down 2. Only objective function 3, 4, 0, 0, 0. Like this. Now come to the point. Now, here is solely first you write down subject point of view. I mean, a point to point. Point to point means solution values. Solution values are, these are solution values. Please remember this. These are solution values. And I mean, this is also called as a solution values are ESV, solution shortcut values. I mean, please enter the values in the tabular form 6, 8, and 11. Finish. Next, first equation. Please see the first equation. Only write down the coefficients. Here is a 1. You write down 1, first equation. Before x2 is a 2. Before x2 is a 2. Before x3 is a 5. 5. 1. No s2, no s3. Okay? Now go to the second equation. Second equation means of only coefficients 2. See, this is a 2. This is a 2. Next go to 4. 4 means write down 4 here. Write down 7. This is a 7. So write down 7. Here is a 0. Okay. 0, uh, 0, 1, 1, 0. Okay. Next, third equation. Third equation means 11 equation. 3, only very coefficient 3, 6, 9, and 3, 6, 9, 0, 0, 1. Now come to the solution. How to write the values in this here, in this area? I mean now see, where is the unit matrix? These are called as unit matrix value. Please follow. This is very, very important. But these are the unit matrix. Unit matrix means here 1, 1, 1. 1. What is the corresponding value? Top value 0 S1. 1 is there. What are the top values? 0 S1. Write down here 0 here. Here is a S1. Go to the second one. 1 is here. 1 is here. Now what are the values? 0 S2. 0 S2. Third one. 1 is there. What are the top values? 0 S3. So 0 S3. Now once it will get, you'll just draw the horizontal line. Forget about the minimum ratio. Minimum ratio is the second iteration. This is the first iteration. Iteration means how to enter the values particularly in the table. Please, I'll explain the point to point. First, write down the simplex table. In the simplex table, these values are standard values. First, CI, basic variable, solution values. If the equation contains 3 variables like this x1, x2, x3, you have to write down x1, x2, x3. So how many slack variables are there? If the 3, then you write down s1, s2, s3. The last column minimum ratio, that is a, just leave it, I will explain the point. Now come to the point. Solution values after equal values are called as a solution values. After equal values, I mean to say that 6, 0, 6, 8, 11. You write like this 6, 8, 11. Okay, next. Please enter the coefficient in the tabular form. The first equation means, I mean to say that first equation is a, this is the one, first equation, this is the one, so that write down 1 here. Next to x2, 2, write down here 2, 5. Next, this is the, before S1, 1 is there, remaining values are 0, 0, enter the value. Like the second equation. Second equation, coefficient 2, see, check it. Here is a 2, here is a 2, 4, 7, 0, 1, 0. Here is a 2, 4, 7, 0, 1, 0. Next, go to third equation, 3, 6, 9. 3, 6, 9, 0, 0, 1, according to this value. And come to the last value. Come to the, this is the last. In the, go to the, in the tabular form, in this table, where is the unit matrix? I mean, and unit matrix values are available from here only. 1, 0, 0, 0, 1, 0, 0, 0, 1. 1. What are the corresponding value? 0 S1. Write down 0 S1. 1 is available here. 0. Okay, 0 S2. Write down 0 S2. 1 is there. What is 1? 1 is there. Write down 0 S3. Write down 0 S3. Okay, sir. So everything is over. And now the computer. Now this is the, in the top. This is called as a CJ. Jth column. I throw jth column like this. This is CI. CI. CJ. The CJ is nothing but the values of CJ are objective function value. What are the objective? 2, 3, 4. Come this 2, 3, 4. See this after conversion the value 0, 0, 0. So 0, 0, 0 over. Next, come to this point. That is next is a ZJ value. This is called as a next row values, or how to calculate ZJ, ZJ values. Next, I will just explain the point to point. Next, next CJ minus ZJ, another values like this. So that this is the, now I will explain the how to calculate the ZJ values and CJ values and etc. Okay, so these are the point etc. So, sir, this is the first iteration. This is called as a first iteration. Go to the second iteration, third iteration. But I can't say the problem will be stopped at the second iteration or third iteration. Depends upon the given problem. But 99.9% problems are solved at second iteration only. So how can no, sir? The problem will be solved CJ, I mean of second iteration. Only the thing is for the maximization, the values of CJ minus ZJ, zeros or negatives. Zeros or negatives immediately stop the problem. So this is a fundamental point of these three important how to enter the simplex table. Once is over, now I'm going to solve a small type of a problem of a simplex method. Okay. Yes. Next, please, another important point. Please note down the points here. Yes, come to this point. The steps for, please, this is a very, very important point. Steps for simplex point. Yes. See, this is a very, very important point. The steps of the simplex procedure. For example, if you want to solve any type of simplex problem, we have to follow this method. Set up inequalities describing the problem constraints. Setup, first point. Setup means sometimes if the equations are given in inequalities, first of all, you have to convert inequality to equal equation, step number one. Step number, introduce slack variables. Sometimes if the equation is given less than or equal to, according to our logical point, introduce slack variables and artificial variables also. Once if we enter into the slack variables, then inequality equations are converted into equal equation. Next, calculate ZJ value. I will explain the point. Next, CJ minus ZJ. Determine the ratio of the column. Ratio of the column means that point is called as a minimum ratio values. Compute the values remaining rows and column. So the point, suppose sometimes if you enter the values in the simplex table, first iteration, second iteration, you check the values of CJ. If the problem is given maximization, for maximization, the values of CJ minus ZJ all zeros or negatives, so that the final solution has been obtained. Immediately stop the problem. So automatically in that tabular form, you will get some x1 and x2, of quotient of values only. Okay, dear students, I'm going to solve one of the small of this. So come to this point. So now, in sometimes, don't think simplex method is suitable for only 3 variables. Simplex method is suitable for 2 variables also. In examination point of view, sometime the question is given like this: z is equal to 10x1 plus 2x2. Subject to constraint is 2x1 plus 3x2 less than or equal to 5. In that equation, you have only 2 variables. Sir, already you told you that if the equation contains 2 variables, so better to go to graphical method. Yes, I agree with your statement. Better to go to graphical method. But in examination point of view, he wants only, you have to solve the problem in a simplex method means you have to follow that method only. I mean of a tabular form method. Now just I'm going to solve the one of the important point is there and point. So please note down this problem. So how to solve the problem? Here is a use a problem is given like this. Use a simplex method maximize z is equal to 5x1 plus 3x2 subject to constraints x1 plus x2 less than or equal to 2, 5x1 plus 2x2 less than or equal to 10, 3x1 plus 8x2 less than or equal to 12, x1 comma x2 greater than or equal to given. Using, but see, if the question is given two variables, better to select a graphical method. Okay, there is a no doubt, there is a no more to argument. But in examination, he mentioned simplex method. That is very, very important point. So that you have to use only simplex method. Don't use graphical method. If you use a graphical method, you are, I mean, so you never get the, I mean, so the examiner will be cancel your solutions. So conversion. So what are the logical point here? Our logical point, please note down what is the logical point here. Less than or equal to, greater than or equal to. Less than means introduce yes, artificial and yes. It means how to convert the inequality to equal equation. Now this is a come to this point. Here is a x1. So x1 plus 2x2 plus, okay, x2 plus 1s1. First equation write down 2. Second equation 5x1 plus 2x2 plus 1s2. Second equation. Sometimes if you write 0 1 0, no problem. So 3x1 plus 8x2 plus 1s3 is equal to 12. Now x1, x2, s1, s2, s3 greater than or equal to 0. Please convert the objective function also. This is objective function. So I would write 5x1 plus 3x2 plus 0s1 plus 0s2 plus 0s3 over conversion inequality equation to given. Now enter into the tabular form. So please write down the simplex table. Okay, so first you write down heading is a simplex table. Tabular form table. Okay. Now how many variables? Two variables, three artificial, 5 columns or 6 or whatever it is. First you draw the horizontal line like this. And first this is fixed. Fixed means CI. CI. In the case of basic variables, so that I have to write down BV shortcut. BV, basic variable. Next one is a solution value. SV stand for solution value. How many variables are there? This is the first column. First column. This is second column. Next, two variables, x1, x2, three variables, s1, s2, s3, and the last one is a minimum ratio. Fixed minimum ratio. Okay, please write like this. Next, the top one is a what are the values here? What are the values here? This is the values. This is called as a CJ. This is the, okay, write down like this, like this. Cj means objective function values. Top equation 5, 5, 3, 0, 0, 0. Okay, this is a simplex table. Now how to enter the quotient? Take the first equation, solution values. These are the solution values. These three equations are always called as a solution values. Okay, solution values. So that is a 2, 10, 12. Now come to the x1. Take the first equation, write down only quotients 1, 1, 1, no s2, no s3. Go to the second equation, 5, 2, 0, 1, 0. Third equation, 3, 8, 0, 0, 1. Now solution. Come to this point. Unit matrix is there 1. What are the top values? 0, S1. Write down here first row 0, S1. The second value is 1, 0, S2, 0, S2. Third value 0, S3. Okay. Now this, draw this one. Now ZJ. First you write down how to calculate the ZJ values. See, ZJ is nothing but sigma Ci into Xi. What is the Ci? Ci, this is Ci. Xi, I is nothing but 1, 2, 3, 4, where I is equal to 1, 2, 3, 4, so on. It means that they take 0 into 1, where I is equal to 1. Supposed to say that 0 into 1, take the first box value. So how to calculate this value? So 0 into 1 plus sigma means addition. 0 into 1, like 0 into 1. Okay, plus 0 into 5 plus 0 into 3. So 0 into 5 plus 0 into 3, all are equal to 0. So write down 0. Don't calculate SV value. SV is not important. Only our values are x1, x2. Like this. Like this. 0 into 1 plus 0 into 2 plus 0 into 3. ZJ value 0. Like this. 0 into 1 plus 0 into 0 plus 0 into 0. 0, 0, 0. Okay. ZJ, the basic concept formula of ZJ is equal to Ci into Xi. Next, the question is Cj minus Zj. Cj minus Zj. In some textbooks, Zj minus Cj, both are same. It's no problem. But don't refer number of textbooks. Cj minus Zj. Cj means C 5. Zj means 0. Same column wise. See the Cj 5 minus 0 0 5. 3 minus 0 3. 0 minus 0 0 0. Okay. Please refer the steps. In the steps Cj minus 0. So this is called as a, see, listen, this is, if you make one box, this is called as a key column. This is called as a key column. If you write like this, if your design is like this is called as a key row. This point is called as a key element. Key element. Now come to this point. How to select the key column? Key column in the Cj minus Zj, select a maximum positive value. Here is a maximum positive 5 and another is a 3. Sir, in some time, if I'll get 5 here and 5 here, so which one is suitable for the given problem? You take any one, you both are same. So always give the first preference to highest value. This is called as a key column. So for the key column, make a small box like this. This is called as a key column. Come to the point of next step, key row. First key column. Now subject on. Then I'll explain the point. Now first to convert simplex equations into the inequality to equal equations, and I write down the simplex table. In that simplex, enter into all given coefficients in the simplex tables. Okay, and after that, Zj value. What is the basic formula of Zj? Zj is given like this only. So what is this? Cj minus Zj xi, Ca into xi. What is the Ca here? Here is a CI 0 into 1 plus 0 into 5 plus 0 into 3, 0. Like the 0 into 1 plus 0 into 2 plus 0 into 8, like all are equal to 0. Cj minus Zj is equal to this one, key column. Next, minimum ratio. The next step is a minimum ratio. Minimum ratio, the basic formula minimum ratio, simple logical formula, SV by Kc. Solution value by key column. Kc means key column. Where is the solution? 2. 2. Solution 2 divided by 1. 1 because this is a key column. 10 divided by 5. 10 divided by 5, that is a 2. Okay, 12 divided by 3, that is equal to 4. So for key column, you always select the higher element. For key row, select the minimum element. You always select the minimum element. It means make a box. So this is called as a key row. So key row and a key column. Key row and key column. This is called as a key element. See this one. So what is this? Vertical point is called as a key column. Horizontal point is called as a key row. The center point is called as a key element. Key element. Now this is a first iteration. This table point is called as a first iteration. Now go to the second iteration, third iteration, etc. The problem is not complete. Zeros or negatives. See, Cj minus Z. Please refer my points. In the last point I already mentioned. In the Cj minus Zj, all values are zeros or negatives. Immediately stop the problem. If you have any one positive value, again you will continue the problem. Here is the Cj minus Zj. All are zeros or positive. It means this is a first iteration. Okay, first iteration.